Wyoming has been the #1 coal-producing state in the country for decades. However, the industry is facing new challenges such as stricter emissions regulations and cheap natural gas prices. To keep the coal economy of Wyoming robust into the future, it is imperative to find new and improved ways of utilizing this carbon-rich resource. Today, researchers at the University of Wyoming are working hard to develop and engineer groundbreaking technologies for various coal capture and conversion technologies. The Peabody Advanced Coal Technology Laboratory, housed in the Energy Innovation Center, is a hub for some of the coal research taking place at the University of Wyoming's Laramie campus.
We are studying coal gasification, which is like an incomplete combustion process where we convert this solid coal into a mixture of carbon monoxide and hydrogen called synthesis gas. And the reason we do that is because we can take that gas, we can convert it to electricity with minimal carbon dioxide emissions, we can make liquid fuels out of it, we can make chemicals out of it, and there's a whole raft of useful things that we can make out of coal. This has been practiced for a great number of years, but we're trying to add more science to the study of gasification. The reason we want to do that is we want to build better gasifiers, do a better job, and do it more economically.
Set up for Fischer-Tropsch process.
Coal char gasification using this
CO2 reduction of about 20%.
We can then take that methanol and use it as a starting point.
Additional coal research taking place at UW is being led by UW Professor of Chemical and Petroleum Engineering, Dr. Maohong Fan, with the ultimate goal of reducing or eliminating emissions from the use of coal. Dr. Fan's group conducts carbon capture and high-value utilization or conversion research with reduced energy consumption.
This is an additional setup for Fischer-Tropsch process. The difference between what I am doing and Ms. Lily He is doing is she is using compact-based catalyst, and I am using aero-based catalyst.
I'm studying pre-combustion carbon dioxide separation. The objective is to separate carbon dioxide from other gases at high temperature and high pressure using a regenerable, inexpensive sorbent.
To improve the capture of CO2 and other pollutants from conventional coal combustion, researchers in Fan's group are looking at novel approaches to chemical loop combustion processes, as well as techniques to significantly decrease energy consumption in the process.
And basically, here we are using a high pressure, high temperature, which is used for aqueous reaction for capturing CO2. And as well as we did some work previously on the conversion of carbonate and bicarbonate, and we have some promising results.
Catalytic coal gasification is one approach to finding different uses for coal beyond traditional power generation. This process uses new composite catalysts prepared with Wyoming minerals for significant reductions of methane and syngas. This syngas is then used to produce value-added fuels such as diesel and gasoline, and chemicals such as ethylene glycol.
The objective is to obtain the synthetic oil, the gasoline, the diesel from the syngas.
What I'm doing is coal gasification. Coal gasification is a very important technology that produces syngas, the hydrogen, and the carbon monoxide. We know that hydrogen is very important.
Different reactors, catalysts, promoters, especially rare earths and supporting materials, are currently being tested by Fan's group for improving catalytic coal gasification and syngas conversion techniques.
My research project is based on fuel cells. I'm trying to find an inexpensive replacement for platinum to catalyze the oxygen reduction reaction in a fuel cell.
For testing ethylene glycol production technologies, researchers are focused on developing new cost-effective, stable, and efficient catalysts to overcome environmental pollution issues associated with conventional preparation methods. Dr. Fan is committed to the development of advanced coal and natural gas conversion technologies, while also training the next generation of high-tech human resources in the clean fuel and chemical production areas.
Various reactions, and you can coal extraction process.
Of a high capacity for CO2 capture.
My research project is about methane aromatization. It's about turning natural gas.
With continued R&D in applied carbon engineering technologies, Wyoming's coal and natural gas markets will remain strong while significantly reducing CO2 emissions. To learn more about coal research at UW, visit www.uwyo.edu/SER.